Hi everyone, it's Mrs. Acker. I'm here to give you a new lesson today on section 5.3, which is on percent problems. We've been spending some time on how to convert percents to decimals and fractions and make that all usable. So I hope that you're finding that pretty easy right about now, or that you've had some practice with it. So today we're going to look at how you can use that information to solve word type problems. So if we go to your textbook, Math Makes Sense, today we're going to start on page 260. And so we're just going to go through a couple problem questions, and then I'm going to give you some questions to do for practice. I thought that I would go through a couple of these and just show you my work. It looks a little bit different than what the textbook uses, so use whatever way works for you. For 5.3 here, the first question talks about a girl named Tasha, and it says that she conducted a survey of the students in her school. From the results, Tasha calculated that 60% of the students go to school by bus. Liam knows that 450 students go to school by bus. So they just kind of told us, if we pause here, that those are the same, that 60% is the same as 450 total. But we don't know what the actual total number is. So they want us to figure that out. So if we go to, here it is, kind of like my work, I decided to just write it out and summarize it so you can see how I'd solve it. So 60% take the bus to school, which is 450 students. So we know that 60% of the total number, whatever that is going to be equal to 450. So usually when we try to figure out a percentage of a number, we take that percent and change it into a decimal and then multiply it by the total to get whatever portion that is. Because we don't know what the total is right now, we're just going to call it x. And so we're still going to convert this into a decimal to 0.6. So you can divide by 100, or you can go whoop, whoop, and move the decimal place 2 to the left. So 0.6 times whatever that missing number is, times x, is equal to 450. If we even shrink it down further, it would say 0.60x, right? Because these are multiplied, is equal to 450. So now that we have a little equation here, we can just solve for x. So to get x all by itself on one side of the equation, we have to do the opposite of whatever's there, do the opposite operation to both sides so that x is all by itself. So in this case, we're multiplying, right? 0.6 times x. So if we're multiplying, we're going to do the opposite operation to get rid of that. So the opposite of multiplying is dividing. So we're going to divide 0.6 to both sides. And so when we divide these two, they cancel each other out because any number divided by itself is 1. And then on this side, we'd go 450 divided by 0.6, as you can see here. So it's actually equal to 750 people total. So the question goes on to say that Tasha says 50% more use the bus. So we could also write this out with a bit of a timeline. Is that what they call it? They call it a number line. Sorry. So we can write this out with a number line, and I always start from 0 to 100% because that's easy. And then we know that 50% is 450 students. Actually 60%, my bad, is 450 students. And we know now that 100% is 750 students. Okay, so we know that another portion of it, walk or drive. So if we want to figure out the 50% of the total, now we're going to, again, convert this into a decimal, 0.5 times the total, 750, which would give us approximately 375 students, walk or drive. So the number line is just a bit of a visual to help us through that. If we go to the next kind of section in the textbook, you can see that they use number lines even to estimate height. And then we're going to go to a different type of problem. So in this problem, they're going to tell us that 70% of a number is 63, but we have to figure out what the actual number is, kind of like in the bus example. So if 70% of a number is 63, what is the number? So here's our number line again, 0 to 100%. We know that 70% of the number is 63, but we don't know what the 100% is yet. So that's what we have to find out. So 70% of x, or taking that 70% and converting it to a decimal, right? Whoop, whoop, 2 decimal places to the left. 0.7x, right? The unknown total, or 70% of that unknown total is equal to 63. So once we have this equation figured out, now we just have to get x all by itself. So we divide to both sides because right now this is being multiplied. So we want to do the opposite to get rid of it. So 0.7 divided by 0.7 is 1, and 63 divided by 0.7 is 90. So that means that 90 is our total amount. Okay, let's try another one. The next one says 175% of a number is 105. What is the number? So now we're talking about a percent that's over 100. So in this case, I went 0% to 100% still. And then I extended the number line a little bit further to 200%. And I said, okay, 175% is around here. And we know that 175% of this number is 105. But what we want to figure out is this value right here. This is our x. So 175% of, who knows, is equal to 105. So again, if we turn this into a decimal, whoop, whoop, this time, because it's over 100%, it's going to be 1.75 times x, our unknown, is equal to 105. And so to get x by itself, we're going to divide. So we're going to divide this to both sides, and these cancel out. And so 105 divided by 1.75, if you put that in your calculator, is 60. So that's B. All right. Yeah, example number 2. Now we're going to look at it in terms of a word problem. So if we're going to increase or decrease something by a certain percentage, okay? So this one says a length of 30 centimeters increased by 40%. What is the new length? So the way that I did this one is I said, okay, I'm going to take 40% of this total, and then I'm going to add it to whatever the total already was because we're increasing. So 40% turns into 0.40. And then if I multiply that by the total, I get 40% of 30, which is 12. And now because I know that it's increased by 40%, I'm going to add the 12 to the original. So 30 plus 12 is equal to 42. 42 centimeters total. There's another way that you can solve this one. In your textbook, under the another solution, they look at it a different way and they say, okay, well, you can add the percents together first. So we could say 100% is what it's at, plus another 40%. And so we're actually calculating what 140% is of the original number. So we could, again, turn that 140% into a decimal. So 1.4 times 30 is equal to 42. So just another way to do it. The next question says that we have a mass of 50 grams and it's decreased by 17%. What is the new mass? So same idea. We're going to calculate whatever the 17% of the total is. So we take that percentage and we turn it into a decimal, right? 2 decimal places. And then we're going to multiply it by the total, which is 50, and we get 8.5. So 17% of 50 is 8.5. And now, because it says it decreased, we're going to subtract that from the total and get 41.5 grams. Again, another way that you can do this that they show in your textbook is, again, with the percentages. So if it decreased by 17%, you could actually think of it as 100% minus 17%, which is equal to 83% of what the original was. And then you can take that and turn it into a decimal, multiply it by 50, and get 41.5. So a couple ways to do it. All right, and then the last type of question is going to be on, similar to the video clip that I shared with you yesterday on percent problems. So this has to do with percent increase or decrease. So if we have like a price of something like a carton of milk, okay, if it increased from 95 cents to $1.25, what was the percent increase in price? So to solve this one, there's a couple steps that I found useful. So first off, we have to kind of summarize our information in the same units. So 95 cents, and we're going to change this one, $1.25, to 125 cents. So now they're in the same units, and now we can compare them. So once we have the same units, now we're going to find the difference. That's our second step. So take the bigger number, subtract the smaller number. So we have a 30-cent difference, right? Or a 30-cent increase. But we still have to figure out what the percent is. So we're going to take that difference and we're going to divide it over the total original. So 30 cents divided by 95 cents, that was the original price, gives us 0.31578. And now we're going to convert this number into a percentage. So we multiply by 100, right? And because we're talking about percents, we usually want to round it. So this one would be 32, right? 32 out of 100, or 32%. So overall, the carton of milk increased in price by 32%. Okay, let's take a look at one more. The price of a green salad decreased from $2.50 to $1.95. What was the percent decrease? So same series of steps, except now we would just say that that percentage is what went down instead of what went up. So first, we have to have the same units. So lucky for us, they're already in the same units. They're both in dollars and cents. Second, we're going to find the difference between the two. So biggest number minus smallest number. So 55 cents difference. And then third, we're going to divide, again, the difference over the original price. So 55 cents was the difference divided by $2.50, which is what the salad originally cost. And we get 0.22. And then lastly, we take this decimal, convert it into a percent, whoop, whoop, 22%. Okay, so those are a couple examples in your textbook today just to start you off. As far as the practice goes, today you're going to do all of the check questions. So there's 4 of them, 1, 2, 3, 4. And then there's some apply questions. So I'm going to try to follow a similar format that we did in class. So I'll let you pick 3 different apply questions. And then I'll let you pick 1 take it further question. And there's 3 of these at the end. So you guys will do those for practice, and then I will post up a key for you on Friday so you can mark yourself and ask me any questions that you might have in Hangouts. And then on Friday in math as well, we're going to do a quick percents formative quiz, just a little practice quiz, just so you can get some feedback and see where you're at and what you're understanding. And then we'll be wrapping this unit up very shortly. So good luck today, and we'll see you on Google Hangouts later.